Scoping, or lexical scoping, sounds really confusing, but to clarify, it's just variable access at the current scope and the parent scope. For example, you have a global scope, a class scope, a function scope, and a statement scope. For example, let's say we created a variable in the global scope. That variable is now available at all the scopes. For example, the class, the function, and the statement, because they are lower than the global scope. It's critical to remember that with lexical scoping, you cannot go backwards. For example, a variable that exists in the statement scope cannot be accessed from a function class or even the global scope. Let's talk about scope. Now, scope is a bit confusing in C++ because we don't really explain it until you explain C++, but you can't explain C++ without talking about scope. It's vastly confusing. So at its core, what are we talking about here? We're talking about where a variable lives, and we have this red circle, this x, this is a variable. This gray is the global or the application scope, which means everything inside of your application. Then we have a class, and we can actually put in class. Then we have a function, and I realize it's going to overlap, and then we have a block of code. This would be like a if statement or a do while loop or something like that. Now, where does x live? Notice how I have this arrow pointing down. Think of this as going over to the right and down, meaning the lower you go on the stack, the more granular you're going to get. So here's x. If we make it in the global scope, it's available to everything else, the class, the function, and even the block. If we make it in the class, it's available to the class, the function, and the block. If we make it in the function, it's available to the function in the block. And if we make it in the block, this is where it gets a little confusing because sometimes you can actually access it in the function, but usually it's only going to exist in the block. This is what I mean by it gets super confusing sometimes because someone's going to say, now wait a minute, can't a function return some sort of variable here? Absolutely can. But remember, we're making a copy usually, unless we're returning a pointer or something of that nature. That's why it gets so confusing. So why does this even exist? Well, if you take this and let's say you have an x and an x, and let's make another one. Which x are we talking about? This is naming collision. And while we're on the topic of naming collision, let's say we have yet another x. And this one lives up in the global. How many x's are these? 4. But in memory, each one of these is independent. This is why scope exists. We want to know which one of these x's we're talking about. Are we talking about the global scope? Which, by the way, this is why we use namespaces in case we have multiple x's up in the global scope. Then we would define which namespace they belong to, and then classes. This x belongs to this class, this x belongs to this function, and this x belongs to this block. This is the fundamental concept you really need to understand, is that scope, when we talk about scope, it's to avoid naming collisions. That's really all it is. And then we have some encapsulation. So for example, the class x should not directly modify the block x or the function x. This is why copies exist. This is why we make copies automatically in C++ to avoid this type of issue. Let's take a deeper look at scope and why we need to avoid naming collisions and data corruption. So newbie programmers are also like, you know what, I'm not going to mess around with all these copies and names. I'm just going to make an X out in the global scope. And you know what, every part of my application can just use that. It'll be good just like that. Trust me, this will just work the way I want it to. And then you have your class, your function, and your block. And we can actually just try to select multiple of these. And let's make another class with another function and another block. Let's go here. So now we have two of them, and this guy right here is our app. and they're happily using X out in the global scope. So the problem is, let's just say this is going to use, and this is all the same X, so I'm going to change the color here. It's going to use this by ref. It's going to say, you know what, we're going to change this out in the global, and we don't care what anybody says. So each code block in two different classes, two different functions, is going to modify this guy right here. Let's say this starts off with 0. Okay, both of these are going to read 0. Not a big problem here. But let's say this one changes it to 200. This one is running, and it expects this to be a 0. You now see we have data corruption. It gets vastly more complex when we get into the concept of threading, where these two blocks of code could be running on two different threads at the same time. And let's say this one changes it to 200, and this one changes it to 1,000, and they're both modifying this global variable. That is a very bad situation, because then we don't truly know what the value of that is, and we now have data corruption. This is how programs crash. This is how programs die a horrible death. So looking at this, you get a really good, solid understanding of why we need scope. We need to save us from ourselves, because we are only human and we are going to cause very bad problems in our applications. So if we want to really avoid this, a variable should be declared at its lowest point in the application, or the smallest scope. Meaning if you only need it in this block, declare it in the block. If you only need it in the function, declare it in the function. If it needs to exist in a class, declare it in the class, not as a global variable. Let's talk about the difference between scope versus namespace. And if you Google it, it's abundantly confusing. Scope is a more general term than namespace. Every namespace class and code block defines a scope. So a namespace defines a scope in which names declared inside of it. That means a namespace simply declares names. Scope is where you declare variables. A namespace is a container, keyword here, container, for names declared outside of classes and functions. What does that mean? That means when you're in a class and a function, things we've already talked about, you're in some type of memory container. If you're outside of those, for example, in the global scope of your program, then you are in a global namespace, or the application namespace. And let's go ahead and define this. So let's say I like cats, so I make a cat class. Well, the problem with that is cats are, well, pretty popular, especially on the internet. So somebody else comes in and makes a cat class. And then someone else makes a cat class, and so on and so forth. And millions of people make their own cat class. Each one of these does something slightly different. So to do that, I'm going to change the colors around just a smidge. Actually, I'm going to do it a lot just so it's abundantly clear they're different. I was going to do like these fancy little artistic gradients, and now I'm just not going to do that. So we have 3 very different cat classes. The problem is they're all named cat. So if you go to create a cat, which cat are you creating? How does C++ know? You're going to get, cat is ambiguous, or just, name already exists, or some other horrible error, and it will not even build. So now we have to introduce the concept of a namespace. And let me grab this rectangle here. And we are going to just have some fun time here in drawing land. So this is going to be a namespace. I'm going to send that to the back. And then we're going to make another one and send that to the back. So now we have different namespaces. Think of this like a boundary in memory where names can exist. So now cat, cat, and cat can all exist without bumping into each other. And under the hood, it looks something like this. You have : cat, although we don't need : it just exists. And then we have like Bob's cats. And I know you've seen the STD, where we've done like cout, things like that. You'd have the standard That'd be awesome if there's a cat class in the standard library, but you get what I mean. You have different namespaces. And the colon colon is the scope operator, meaning we're going into a specific scope and we're determining which one we actually want. So that is how scope differs from namespace. Now, inside of cat, you can have your own variables, functions, properties, things of that nature, and each one of these can drastically be different. Scope gets very, very confusing, and there's different types of scope. And I want to touch on this very briefly. We're not going to spend a ton of time, but we're talking about static versus dynamic scoping. And when we talk about static, this is different than a static variable, something we'll talk about later. But static versus dynamic. Static is often called lexical scoping. Think of it as a top-down approach. We keep saying top-down because it makes sense. And a big shout out at geeksforgeeks.org. This article really hits a home run with explaining it. I'm just going to walk you through it super quick. Basically, there's two types of scope. Static, also called lexical, top-down, and it refers to its top-level environment. We've talked about this before. Make a variable where it's needed. Don't make them all over the place. And it shows a really good example of some of the issues you can have here. So here's a C program. Remember, C++ is built upon C, where in the global variable, see if I can get this to actually work. There we go. We have this int x equals 10. And we have a function that's returning x, basically returning the value that's stored in the global variable. But then we have this other function down here called g, which is making x or rewriting it. Remember, we talked about collisions. And then we are equal 20 here. So on the global, it's 10. In F, it's returning the global, which is 10, and G is 20. And that just has this very simple example where it's going to set X to 20 and then print it out. And we've done something very similar where you don't get the output you expect. You're seeing G and you're thinking it's going to be 20, but really it's going to be 10. That is why scoping is so confusing. When in doubt, try to avoid naming collisions and try to avoid putting things in the global scope. Sometimes you just can't help but make a global variable like they've done up here. But when in doubt, try to avoid that. Now, dynamic scoping, the global identifier refers to an identifier associated with the most recent environment. And this is why most modern languages stray away from dynamic scoping, because that scope can jump all over the place. And here's a great example, almost virtually identical, where you have global x10, F is returning the global x, and then G is defining its own x at 20. And when you run this, of course, you get a completely different output of 20. Oh, that is frustrating. When you think of scope in C++, think of lexical or static scoping. Always think from the top down. This video is going to focus on function scope. Now, why? We need to really solidify this. Functions have their own scope, but they share with their parent scope. That is the foundation of lexical scope. We need to really understand this and really drill this in. Now, admittedly, some of this video you're going to go, we've talked about this before, and some of it you're going to be scratching your head going, wait, what? So let's just dive in and take a look. So I'm going to say int number. Let's give this a value of 75. Now I'm going to print some things out on the screen, and we're going to do this in steps. So I want to be able to see step 1, step 2, step 3, step 4, and I want to be able to walk through memory as this thing's running and see exactly what's going on. So I'm going to say qinfo. And I want to say 1, and then number is. And here I'm going to do the address of, and I want the address of that variable. That way I can see exactly where in memory that thing is. And I'm going to say equals, and then the actual value. The end result, when we run this, is going to tell us what step we're on. Step 1. The number is at this memory address, and it is this value. All right, now I want to create a function. Notice the name of that parameter. Number. Number. Do we have a naming collision? No, we don't. Why? Because those are two different scopes. Allow me to demonstrate here. So I'm going to take this, plop it up here. This is going to be step 2. And we're going to call that. If you ever want to confuse somebody, do code like this, because they're going to say, wait, here's number, here's number, here's number. That's all the same number, isn't it? Let's run and find out. You notice how step 1, step 2, memory addresses do not match. These are two different things in memory, even though they have the same value. So we are talking about two distinctly different things living in the RAM of your machine, which means we can do something like this. Number equals 50. And then let's go down here, grab this. And say step 3. And let's just run. We've seen this before, but I want to really solidify this bad boy. So step 1 is in our main function. Step 2 is in that test function, and step 3 is in the main function again. You can see the memory addresses of 1 and 3 are the same, which is why their values stay the same. So that is scope happening right there. Scope is protecting us from doing that. In the background, we're creating a copy, and it's being copied right here. Now, all of that seems, well, abundantly confusing. And it is. It is very confusing. However, we can take this even a step further. We can grab this and say, bool, okay, and let's go ahead and say true. And then if, and I want to say, okay. So what are we doing here? We're creating a block of code. Now this also is a separate scope because we are in a block of code. And I'm going to actually just, every time there are these little brackets, I'm going to put the word scope just to really solidify this. This is lexical scope at its finest right here. So what's happening is this is all one scope. And inside of it, we have a block of code which has its own scope, but of course, lexical scope, we can go down. That's the dangerous bit here. So if I save and run, you're going to notice how step 3 hasn't changed. See? But we can do something like this. Number equals 1000. And then let's go ahead and jump off to step 4. So you may be thinking, okay, that's a block of code, so that's its own scope. Very true, but it shares its scope with its parent, this guy right here. So in step 3, we're now actually modifying this guy. See what I mean? Memory addresses. We have modified that. That's a big no-no. That's bad. That's very bad. The reason why that's bad is if we didn't intend to do that, we would have had a very bad time. Now, C++ does save us a little bit because if we try to do this, what's actually going to happen now? Let's save this and let's run it. Notice now we have on step 3 a completely different variable, even though they're all the same name. Isn't that confusing? And we don't get any name conflicts. So under the hood, C++ is saying, well, we're going to use lexical scope because they didn't declare a new variable. However, they're declaring one now, so we're going to just make a whole new one and ignore the parent scope. That gets confusing, and this is very, very error prone. So if you're ever working with something like this, be very, very careful. The general rule of thumb here is you want to declare a variable at its lowest position in the code, meaning if you're only going to use it in this code block, don't declare it up here. Only declare it up here if you're going to use it top down, meaning this will come back and haunt you. I'm going to put that in bold letters. This will haunt you. Because you'll be sitting there trying to figure out what's going on because it's the same variable. And C++ allows you to compile, build, and run without any errors, and it doesn't even warn you what it's doing. We're going to focus on scope in classes. Why? Because classes have their own scope, and classes do not share scope with each other. Remember, a class is a blueprint, and then I have in parentheses, unless it's a static variable. And this is what I mean by C++ and, well, most programming languages, but especially C++. They will utterly confuse you because they'll make a rule like classes do not share scope, but then they give you the means to break that rule. So it becomes very confusing about what you're supposed to actually be doing here. Now, a static variable, in case you've never heard of it, we're going to cover it later, is basically every instance of a class shares the same variable. Doesn't matter if you have 1 or 1,000,000 instances of that class, they all share the same variable. It gets really, really confusing. So let's just focus on classes for the moment here. We're going to go here, we're going to add new, and let's add an animal class. I'm going to keep this class very, very simple. This is just simply a demonstration on scope, not so much on classes. And let's go in here. All right, so now that we've got that in there, we can go in and modify this. And this is going to be just ridiculously simple. Again, we are focusing on scope. And I'm going to go in here, and we are going to string name. Now, what are we doing here? We're violating some things that we've already said. We're making this variable public. We don't have a getter or a setter. So somebody out there is going to notice that. The reason why that's dangerous is because we can modify this without warning. And we're going to go in here and modify the constructor as well. Notice the name of the variable, or the name of the parameter, and the name of the member variable here. So you have name and name. Which one is which? That gets really, really confusing. And we're going to give that an initial value. Let's go ahead and switch over to our source here. See this out of line definition? It's because we modify the constructor. It's really all that's going on there. And then from here, we are going to say this dot name equals name. Why are we doing this? And when I say dot, Qt Creator is automatically putting this arrow in here. In case you're doing it on a different IDE, you may have to manually type that. But in Qt Creator, I just press the period and it does it for me. However, if we omit the this keyword, C++ gets very confused about which version or which variable of name we're talking about. Are we talking about this variable here, the parameter that's being copied, or are we talking about this variable here? So we have to actually define the animal name. All right, that gets really, really confusing. All right, from here, I am just going to, for the sake of speed, copy and paste some code in here. So we're going to say the animal name param, and then we want the animal name. And let's go ahead and put that just to show that those are two very different things. And then I want to go into the header here, and I want to make a function. I'm going to say void say hello. Very simple little function. Really no rhyme or reason to this. And all we're doing is we're just going to print this thing out here. So I'm going to do the magic of copy and paste, put some notes out here. So notice message is going to be the same. Now let's look at name when we run this thing. Give this a good build. It's warning me about something here. I probably got a little too copy and paste happy. Unclaimed breakpoint. In case you're wondering what that was, I must have clicked off in this gutter here. When you get a little bit more advanced, you can use the debugger down here, and you can set breakpoints. So when you debug, it will stop the execution at this breakpoint and show you exactly what's going on in memory. It's a little bit time intensive, which is why we haven't been using it. It also gets to be a little bit more advanced than what we've been talking about. So let's go ahead and include our animal class. And let's go ahead and use it. So I'm going to say toString name. Notice that variable name. And then let's just go ahead and do a little bit of copy and paste action here. My name is at, and then the address of whatever the variable is, and then the value. Now we can go ahead and make some instances of this. I'm going to say animal, we'll say cat, and I'm going to give it the address of A, which in case you're going, wait a minute, what's A? It's this Q core application right here. I'm just giving it a parent. And then I'm going to say name, let's call this Fluffy. We don't have to give it a parent. I could have given it a null pointer if I wanted to. And we're just going to make a few things here. So I'm going to say dog. And then person. Probably should name these something else like Fido. And let's use name here. There we go. Then I'm going to say person dot say hello. I'm just going to say hola. And then let's go ahead and do info out a person name. Notice how we can access that name because it's in the public part of that class. Very dangerous that we could do that because we could actually assign a value here. All right, let's save and run and see what this whole mess looks like. Oh, we've got a whole bunch of stuff to walk through here. So my name is at, and there's the memory address of Brian. And then we have the animal param, Fluffy, and then Fluffy, and then Fido. So what does all this really mean? If we're really, really sharp at tracking memory addresses here, which is why we often do the set object name, you can see, well, this is a mess. This gets very confusing to figure out what's going on, but the main takeaway here is that they do not share things. So when we set the cat name and the dog name, those are two different names. And just to solidify that, let's do something like this. Let's go cat.name equal my cat. Dog.name equal my dog. We're just going to make this overly simple just to really hammer this home. And I'm going to say cat name. And dog name. When we run this, look at the last two lines here, and there should be two very different things. My cat and my dog. These are two very different objects. They do not share scope. So every instance of this class has its own little island of scope, and you can do some really awesome things with it. But the major takeaway here is that, yes, you can really make some confusing things happen here. And you can have some naming collisions just in your own class scope, as we saw right here. We have to say this name, otherwise it thinks we're trying to modify that right there. And if we wanted to really overly simplify this, we could just, through the magic of the toggle comment selection, get rid of a lot of this. Just look at one object, or I should say one instance. You can see just how much is going on in the background in C++ here. So we have a string, we have the animal name, which is actually the person, which is right here. Now you notice this is 5EEE 4BD0, and this is 5EEE 4BD0. And then right here, we have something totally different. So we have a copy going on there. And then, of course, we have this 5EEE 4C20. Notice the differences here of what's happening. We have multiple variables with the same name. So the other foundational thing you should walk away from this video is that, well, memory address really defines what the object is, or I should say where it is at. So if you have multiple things with multiple names, they're going to be at multiple memory addresses. And I don't know if you really caught on to it though, but notice QString. We are copying QString because QString is not a Q object. So we can actually copy that. Just to kind of drive that point home, let's go on to QString, hit F1. And if we look at this thing, so the header is this, and that's right, it's not a Q object at all. We can really just dive into this if we wanted to. But QString can be copied all day long just fine without any problems because it's not a Q object. Let's talk about global scope. I've mentioned it a few times and everybody gets really excited when they think, oh man, there's this magical place where I can throw all my variables and every single object I could create can magically see them. Yes, that place exists. However, it's a very bad place filled with doom and despair. You do not want to do this. And literally for the reason why we're talking about global scope, I put some people just want to watch the world burn. And I mean that. Do not do this. If you ever want to lose a programming job, follow this video step by step because this is not the way to do things. So I'm joking, but I'm also serious at the same time. Anybody who's really done serious programming will tell you right off the bat, avoid global scope. Yes, I admit it does have its uses. However, those uses are very limited and you want to avoid this at all costs. Typically, when I see somebody doing something in the global scope, I think you haven't designed your program very well. And let's go ahead and demonstrate. So we're going to keep this simple, and at the same time, this will confuse the living daylights out of you. So I'm going to say name equals Ryan, and notice the placement. This is outside of our main. This exists in the global namespace. Yes, that's right. It exists right there. However, because of lexical scope, we can do some really awesome things. And when I say awesome, I do not mean awesome at all. I can say name and notice how it sees it automatically because it's top down. We're going from global into this function scope. I can now assign this. I can say, oh, let's go ahead and turn this into Bob. Well, what have we just done here? Well, we have not created a new variable. We have actually overwritten the global variable. That may be what you intended to do. However, it can get vastly more confusing than that. Let's say we wanted to just fill this out just to verify the name. I just want to prove that, yes, we can overwrite the variable out in the global scope, and sure enough, it now says Bob. All right, not bad. Now let's do something like this. So we are making a block of code, its own little scope. And I'm going to say QString name, the naming here, is Tammy. Uh-oh, what are we doing here? That's right, we have a naming collision. However, C++ is going to allow that collision. Notice the IDE is trying to highlight these are orange, this is blue, so it's trying to make sense out of this madness that we're doing here. However, if we simply do something like this, save and run, what's going on? Notice how Bob, Tammy. So now, how do you tell which one of these is which when you're down here? Well, you have to go by the nearest variable right here. And that's what I mean by if you were expecting Bob and you got Tammy, you're now very confused and you're trying to figure out what the heck is going on. And to make things even scarier, you can do something like this. Notice the color change. So we use the scope operator, go to the global scope, and now we're using this one up here, which has actually been renamed to Bob. So if we save run, guess what's going to happen? That's right. Now we're displaying Bob. See how super confusing that gets? Okay, now let's take this to just another level of madness. What we're going to do is we're going to print this out one more time just because we want to, right here, and we're going to make a function. And this is where global scope really bites you in the backside. So I'm going to say testing. And notice the color, we're using the name out of the global scope. The problem is we've been doing all these modifications and stuff. Now, if we come in here and say testing, how do we know which one of those is actually going to be used? The IDE tries its best to help us out by color coding these. It can figure out which one we're doing. However, if you had zero color coding at all, this gets very, very confusing very quickly. So now we have Bob, Tammy, Bob, Bob, Bob. So what in the heck is going on here? This is why the global scope is just wrong. You don't want to use this because you can very easily accidentally overwrite that variable and there's no warning, no compilation error of any kind. I mean, let's just give this a good old-fashioned rebuild. I'm going to actually close this. I'm going to look at this compile output and we're going to rebuild that whole thing. Nothing, no error, no warnings, no nothing. This has a clean, perfect build. However, if this were a production app, because we just overwrote that name, we have effectively destroyed the application if they were expecting this to be Bob. Let's talk about static scope in classes. Now, this is kind of brain bending when you think about it. Remember when I said that C++ has rules, but then it also gives you the tools to break those rules? This is an example of that. So what is static? Well, when we create something with the keyword static, we're saying that every instance of this class will have a copy of that and can modify it directly. It's different than a global variable. It exists at the class level. And we want all classes to use the same variable. This also can get very dangerous, but it does have practical uses, and we're going to demonstrate both. So I have this simple animal class. It's inheriting Q object, has a QString name, and an int count. We want every instance of this class to modify this. Now, how do we do that? Simple. We just say static. We convert that into a static variable. Now, what's happening in the background is C++ is doing something very similar to making it like a global variable, but at a class level. Kind of confusing the way that works, but basically every instance of the animal class will get that, and it can modify it directly. So we have a constructor and a deconstructor. Let's go ahead and flip into those. At the constructor, I'm going to say count. Go ahead and increment that. And at the deconstructor, we can say count. Decrement that. Very, very simple. Now let's jump out to our main. And let's go ahead and say include animal. Now this is where things get a little bit confusing. So let's go ahead and make an instance of that animal class. I'm going to say animal. And let's call this cat. Let's see how many cats we have. Go ahead and save all. Notice how we get a metric ton of issues right off the bat. So things are not as simple as we think they are. And it says undefined reference to animal count. This gives us a little bit of a clue of what C++ is complaining about. Notice the animal : which is the scope operator. So it's saying in the animal scope count, we can't find this. Huh? What? Well, where's that coming from? So we have to actually initialize the variable, and this gets confusing. We have to initialize it outside of this function here. So I'm going to say int animal count 0. Now let's try that. Now it actually runs and we can see we have exactly one animal. If we wanted to, let's try to make a bunch of these. And let's say, call this cat 2, cat 3. So we have cat, cat 2, cat 3, and we're just going to say cat count. Notice how there are 3 cats, because I think everybody in the world should have 3 cats, but why not? Let's go ahead and run this. Notice how now it is 3. Does not matter if we get that from cat, or we could even rename these to dog and fish. Up if I could actually spell fish, that was embarrassing. There we go. And let's get this from dog. See how many animals we have. 3, ta-da, works as expected. Now this is actually really awesome, and as those are deleted off the stack, you guessed it, it's going to know automatically how many are there. And let's try it this way. So we can get it either way. We can get it directly from a class, or we can get it right from the animal class scope. Now let's play around with this just a little bit here. So I'm going to say, and we're going to take all of this, cut it, and move it up here. Notice what we've done. We've made a scope. These are also on the stack, so they're going to be constructed here and deconstructed here. Remember, in our class, in the deconstructor, we're decrementing this count. Let's flip back over here, and let's see this happen in real time. So 3 are created, 3 are destroyed, we're back down to 0. That is actually pretty cool. Now we can get a raw count of our classes. However, again, C++ gives you all the tools you need to shoot your foot off. Morbid as that sounds, you can actually do it. Somebody out there is going to say, well, I've got this name out here. Let's just make this a static as well, see what happens. Why not? Let's just do that. That looks super awesome. And, oh, yep, I'm super smart, so I know that I have to do it here. So I'm going to say Qstring, and we need to say animal name equals that. Ah, there we go. Now we have a subtle problem here. As we try to work with this name, every time we change this, it's going to end badly. So what I mean by that is, let's say cat.name. Notice how, other than the color coding on the IDE, we're not getting a whole lot of feedback here. I can slow it way down. It's not even telling us it's static. It's just saying Qstring name. So as a developer, without cracking open that header file, I have no way of knowing that's static. All right, so I'm going to say name equals, I have no idea what to name the king. Name the kitty cat. Let's see, call him Gamer? I don't know what to name the cat. I run out of cat names. And let's go ahead and name the dog. And we need a good name for the dog. Let's call him Mud Pie. I don't know why I named him Mud Pie. Anyways, point being, let's just examine this here. And let's say Qinfo. Our cat is named. Let's go cat name. Somebody really observant in color coding is going to notice that these are orange, so Qt Creator's IDE is smart enough to know that this is in the static, not at an actual member level of that class. So when we run this pop quiz, what is it going to print out on the screen when we say cat name? I think I actually misspelled gamer. There we go. Well, if you said the cat's name was going to be Gamer, you would be dead wrong. It's MudPie because it's all sharing the same variable. That's one way you can just completely mess yourself up using static variables. So our counter example worked as expected, but once we started playing around with things we shouldn't, we see disastrous results very quickly. So if you really, really want to confuse a developer, use a static function in a class. That's right, static function in class. Think about that. So static means it exists everywhere, technically part of the class, but yet you don't need an instance of the class to modify it, as we saw with static variables. Why? We want to put a function in a class, but we don't want to create a class. What madness is this? I need to highlight this. Who thought of this when they made classes? It's actually an ingenious idea, but as a developer, it's like, now, wait a minute. Again, the whole concept of a class is it's a blueprint and you want to create an instance of that class, but a static function allows you to violate that rule by using the function without actually creating an instance of the class. Beyond frustrated at this point. Okay, so let's dive in and take a look. When I was first learning C++ many, many years ago, this drove me insane. I had so many questions here. So let's go ahead and just make a Q object. Let's go ahead and go in here. And test.cpp, let's add those in. And this is where we're going to do some stuff. Jump into our test class here. And I want to include Qdebug. Now, I want to add two small functions. I want to say void do stuff and static void do other stuff. And you can name it whatever you want. It really doesn't matter, to be brutally honest with you. Just notice that the do other stuff is a static function. It's got the static keyword in front of it. And then we can go ahead and just add definition. And you notice how in the implementation file, there is no static keyword. We can't really tell without flipping over to the header which one of these is actually static and which one isn't. This gets just confusing. So let's go ahead and do this. Qinfo this. I want to know that this was constructed. Now I'm going to go ahead and do this and this, and I want to say do stuff and do other stuff. Notice how it's already complaining. So it's saying invalid use of this outside of non-static member. Whenever you see non-static member, that's frustrating because what it's telling you is that there is no this. This does not exist. I'm going to put it right here. Maybe put it in quotes. This, the this keyword, does not exist because you don't actually have an instance of the object. That gets very frustrating. Now I'm going to grab this and so we have no current instance of the object, but we can still do code. We're just going to simply print something out. Now we can try something like this. Do other stuff. So we can call that function. But if we try to call this function here, what's going to happen? Notice how call to non-static member, meaning because there's no instance, we can't call this. That gets beyond frustrating. So I'm actually going to move this up here so it's all nice and neat right up in the comments section. But we can still run code without an instance. Again, C++ always gives you methods of shooting yourself in the foot, and that is a great example of how things can get very crazy very fast. So flipping over to our main, We're going to go ahead and say include, and we want to add test. Now we can do something like this, test t, and then t dot do stuff, and t dot do other stuff. Notice in that little yellow box, it doesn't even tell us it's static. We can just do it. Doesn't matter. Save and run. And it works as expected. So it's constructed, we can do stuff, and we can do other stuff. This is working, albeit as confusing as it is, it's working. Now, if I wanted to comment all this out, you can do something like this. Pop quiz, what is going to be printed out on the screen when we call do other stuff? If you look at the implementation, what's going to happen in do other stuff is just simply print out do other stuff. If you think it's going to print out a constructor, you may need to watch the video over again. Let's go ahead and demonstrate. There's no constructor. We can just call code directly. So what is the practical application of making a static function? It's for when you want to be able to run code without having an instance of your class. However, doing so means that you now lose access to instances of the class, as we demonstrated here. We can't call anything that has the this keyword.